David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Okay, today's topic, probability and table data. And what you're going to see in this chapter is we use a lot of tables to organize our probability data, and this helps us make lots of different comments about probability. It also allows us to answer lots of different kinds of questions, which we'll do in a minute. But first off, let's say we're at a school, big school, like 2,000 people, and we're curious about where people were born. So we go through our school, we ask a bunch of people different questions about where they were born, and for simplicity's sake, let's just assume that our school is only represented by these 5 countries. I know that's not realistic, but for the sake of this example, let's just assume with that. And we asked people where they were born. We got 61 people from China, 6 from Nigeria, 13 from Vietnam, 75 from the USA, and 5 from Canada. Now, based on this data, we want to be able to ask a random student where they were born and be able to predict what is the probability that they're from China, or from the USA, or from Vietnam. So this is what experimental probability is all about, and let's do this. Before we go on and calculate our relative frequencies, we need something. Think about that. Pause the video if you have to. What do we need? If you guessed trials, you're right. We need to know how many people we asked this question. That's a crucial number for calculating our relative frequencies and our probability. So that's just received by adding up all these numbers, and we get 160. That's all these numbers added up. And just for grins, how many outcomes do we have? If you thought 5, you're right. There's 5 different answers. There's 5 different outcomes to our question, where were you born? Okay, so now that we know the number of trials, let's put our outcomes here. Now that we know the number of trials, we can calculate our relative frequencies. That's just the frequency over the trials. So this is 61 over 160. This is 6 over 160. This is 13 over 160. This is 75 over 160. And this is 5 over 160. Now, take out your calculator and calculate those numbers, put in a decimal, and then also convert that to a percent. So let's see how you did. I went ahead and did my calculations. You can see I put my decimal and my percentage. This table now will help us determine the probability of a randomly asked person being born in each of these 5 countries. So if we go out into our school, remember like 2,000 people in our school, and we ask them, what country were you born in? There's a 38.1% chance they were born in China, 3.8 for Nigeria, 8.1 for Vietnam, 46.9 for USA, and 3.1 for Canada. So that's how we can use this table to make a prediction based on all the people in our school. Now let's ask a more complicated question. How about, what is the chance that they were born in North America? So instead of just saying USA, now I've asked the question to include Canada. So what's the chance that they were born either in USA or Canada? The way you get that is you just add up these 2 probabilities. So 46.9 plus 3.1 is exactly 50%. So if I ask that question, what's the chance, or were you born in North America? We have a 50-50 chance, or a 50% probability that they're going to say yes to that question. That kind of makes sense too, because we have 75 out of 160, add another 5, we have 80 out of 160. That's exactly half there. So it shows up in the numbers right away in the relative frequency. Okay, now we're going to do a kind of table called a two-way table. And these are very common, and they help us compare 2 populations across 1 question. So in this case, we're asking boys and girls about their musical tastes. Specifically, do you like rap or do you not like rap? Okay, and we asked a bunch of boys and girls this question, and here's the data we got. 57 boys liked rap, and 68 did not. And 53 girls liked rap, and 92 did not. This table is useful, but we have to add something. We need to get our totals in here. We need to find out the total number that like rap, and we need to find out the the total number of boys and the total number of girls. So boys is just 87 plus 68, we get 155. And then girls, 53 plus 92 is 145. And what does that add up to? That adds up to 300. Nice, even, round number. Now let's figure this one out. 87 plus 53 is 140. And 68 plus 92 is 160. Now, if you've done your two-way table correctly, these totals here are going to add up to the same number as these totals going across the columns. And indeed, that worked out. So that's like a check that you have. Okay, here are 3 questions that we can answer with this table. And there's a whole bunch more, but I'm going to focus on 3. What's the probability that the person we ask is a boy out of this data? Secondly, what's the probability that they're a boy and they like rap? So it's getting a little more complicated. Finally, the third question is, what is the probability that it's a girl or they like rap? Okay, so let's do the first one. It's just relative frequency. So we need to look at for our total of boys. We have 155 boys out of 300 total. Remember, our trials here is 300. We asked 300 students this question. So that's the trials. So it's 155 out of 300. Go ahead and pause the video and do your calculation. I get 0.517, which is 51.7%. Now the second one's a little bit more complicated. It's a boy and likes rap. So really, that's just this number. These boys don't like rap. So it's 87, but we still have to count the entire sample, all the people that we asked. So that was our 300. So this becomes 87 over 300, which gives us 0.29, which is 29%. And the last one, this is the more complicated one. Girl or likes rap. So girls, we have 145 of them. 145. We know this is going to be over 300, but we need to add a little more to it because these boys also like rap. And the key here is the or. So our question includes all the girls. What's the probability that they're a girl? So that includes all those girls. That's the 145. Or likes rap. So that would be these two populations. These are the like rap. However, we can't count this twice. This 53 is in the 145. So that's already included here, but we need to add in the additional, the boys, not girls, who nonetheless like rap. So that's 145 plus 87, which gives us 232 out of 300, which gives us 0.773, which is 77.3%. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.